Hello. Hello everyone. Welcome to my channel. So, um today I will be discussing about what we call combined gas law. So, again, wait lang. It's called combined gas law. So, if you can recall the ideal gas law, we have PV equals nRT. This is the what? Ideal gas law. And combined gas law is where you have initial and final states, like um what if what if you have um you have a glass and you have a volume of 2 liters, and the temperature that you're heating is at, since it's STP, it's 273.15 Kelvin, and the pressure is ATM. So this is where we use the ideal gas law, or the PV equals nRT. But what if um during the experiments you decide that you add more volume here, you add another 2 liters, and this is 1 atm, right, at STP, standard temperature and pressure, and you also increase the pressure to 2 atm, and also increase the temperature to what, 300 Kelvin. So this is where you use the combined gas law. You have an initial state. Let's call the initial state P1, T1, and V1. This V1 is 2 liters. And we have the final states. We have P2, T2, and the V2 becomes 2 liters plus the what you've added, 2 liters. So this is 4 liters. So you used combined gas law is used when you have initial and final states. Okay? So this is where you use the combined gas law. So if PV equals nRT is the ideal gas law, this is the ideal gas equation, PV equals nRT. So what is the formula, or what is the equation for the combined gas law? So to derive the formula of the combined gas law, let's write here again. We have PV equals nRT. This is the ideal gas equation, or the ideal gas law. So let's say that we have initial and final states. So the left side is where we have the initial state. We have P1, V1, nRT1. And we also have the final state, P2, V2, nRT2. So note that N and R are what? These are given depending on, or depends on your P, right? If it's ATM, millimeter per mercury, or kPa, or kilopascals. And your N depends on what? The kind of substance you have. your number of mole depends on what compound or what molecule is given. Okay, so this NR here, wala siya, it has no final and initial states. The PV and T are the variables which has an initial state. So um, this will be so this will N will be cancelled here because the number of moles is not relevant in combined gas law. So we have P1V1 equals RT1 and P2V2 equals RT2. So what happens here is R here is equal to P1V1 over T1, right? We combine both sides by T1, and here we delete, we divide both sides by T2. So you have cancel this one, cancel this one, cancel this one. So on both sides you have R equals P2V2 over T2. So the combined gas law here is when R is equal to R. So you have P1V1 over T1, P1V1 over T1, and P2V2 over T2. So finally, this is your combined gas law equation. This is your combined gas law. Combined gas law. So you should remember this one always. P1V1 over T1 is equal to P2V2 is equal to over T2. So let's answer a problem here for examples. We have 4 examples here that involves combined gas law. So a gas balloon has a volume of 106 liters. When the temperature is 45 degrees Celsius and the pressure is 740 millimeter of mercury, this is mmHg, what will its volume be at 20 degrees Celsius and 780 mmHg pressure? So if you read this carefully, you will know that the givens are what? We have given V1 is 106 liters and T1 is equal to 45 degrees Celsius and P1 is 740 mmHg. So initially these are the given: 106 liters, 45 degrees Celsius, and 740 mmHg. The question here is, what will its volume be? What is V2 when the temperature is 20 degrees Celsius? So the temperature decreased from 45 to 20 degrees and the P2 increases to 780 mmHg. So the question here is, what is the final state of the volume? So we add this 273.15 Kelvin plus 273.15 Kelvin. So this becomes 318.15 Kelvin. And then 73.15 plus 20, we have 293.15 Kelvin for T2. So if you recall, the combined gas law is what? P1 P1 V1 over T1 equals P2 V2 over T2. And we're looking for what? We're looking for V. What we're looking for is V. Okay? So we transpose everything. So we first cross multiply. We have P1 V1. We cross multiply from here to here. T2 equals P2 V2 T1. And divide everything with P2 T1 over P2 T1. So this gets cancelled. And we're left with what? V2 equals P1 V1 T2 over P2 T1. So let's use everything that we have. We have P1 740 mHg times V1, which is 106 liters, and T2, which is 293.15 Kelvin, divided by P2 780 mmHg divided by T1, which is 318.15 Kelvin. Therefore, we have $92.66662 liters, because this gets cancelled. So the final answer here, we have after changing the temperature to 20 degrees Celsius and the pressure to 780 mmHg, the volume will become 92.662 liters. So number 2, so I hope you're following. So number 2, if 10 liters of oxygen at STP are heated to 512 degrees Celsius, what will be the new volume of gas if the pressure is also increased to 1520 millimeter of mercury? So I want you to take note that it mentioned here STP. Okay? So we know what's STP, right? Standard temperature and pressure. So at STP, the temperature is 273.15 Kelvin and the pressure is always what? 1 atm. So 1 atm, if you convert this to mmHg, this is 760 mmHg. Okay? So we have again, we have for V1 we have 10 liters. For T2, this is what? Because it says here STP, we have 273.15 Kelvin, and for pressure we have 760 mmHg. So we have to match what the givens, okay? So we have to match the units for the given, so there will be conversions. So we have P1. And then it's asking what will be the new volume of gas. So what will be the new volume of oxygen gas if the temperature, this is not T2, this is T1, because at STP this is the initial state. T2 will be 512 degrees Celsius plus 273.15 K. This is 512 plus 273.15. This is 785.15 Kelvin. So, again, at STP, liters of oxygen at STP, given na ang temperature and pressure. And the pressure here, P2, is 1,520 mmHg. So, we still need to use what we have here in example 1. So, we have V2 equals, what is P1 here? P1 is 760 mmHg. V1 is 10 liters. And T2 is 785.15 Kelvin divided by P2. P2 is 1,520 mmHg, and then T1. T1 is 273.15 Kelvin. So you calculate this. Then so we have 14.372 liters. So this gets cancelled. Cancel, 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 cancel. Okay. So for number 3, we have this problem. A gas is heated from 263 Kelvin to 298 Kelvin. So this is a hint in the given here. We have given temperature 1 is 263 Kelvin and T2 here is 298 Kelvin. And the volume is increased from 24 liters to 35 liters. If the original pressure is 180 m, the question is, what is the final pressure? So, we go back to our combined gas law equation. We have P1 V1 over T1 equals to P2 V2 over T2. And then, we cross multiply. We have P1 V1 T2 equals P2 V2 T1. And we divide both sides by V2 T1. V2 T1. So we can cancel this. Cancel, 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 cancel. Therefore, to get P2, the final equation is P2 equals P1 V1 T2 over V2 T1. And this should be, we plug in what we have. P1 is 180 m, V1 is 24 liters, T2 is 298 Kelvin, divided by V2 is 35 liters, and T1 is 263 Kelvin. So we calculate this. We have we have 0.777 ATM, since we cancel this out. Liters, Kelvin, Kelvin. Okay, the final pressure is 0.77 ATM. So for the final example, we have this. So the pressure of gas is reduced from 1,200 mmHg to 850 mmHg. So pressure in given P1 is 1,200 mmHg. And pressure 2 is 850 mmHg. As the volume of its container is increased by moving a piston from 85 ml to V2 350 ml. would be the final temperature if the original temperature or the initial temperature is 90 degrees Celsius and temperature 2 is what we're looking for. So we have the givens here. We have P1, V1. Let's use the combined gas law. P2, V2 over T2. P1, V1, T2. We cross multiply here. And P2, V2, T1. So P1, V1 over P1, V1. Therefore, T2 is equal to P2, V2, T1 over P1, V1. Hence, T2 is equal to P2 is 850 mmHg, V2 is 350 ml, and T1 is what? Don't forget to convert this to Kelvin. So this is 90 plus 273.15. This is 363.15 Kelvin. 363.15 Kelvin divided by P1 is 1200 mmHg and V1 is 85 ml. So notice that I know we always use liters, but don't you just need to match this, okay? So if the all givens are in ml, so it's okay, but you need to convert one if it's not the same, if one is ml and one is liter. So this case it's okay, in this case it's okay. So we have cancel this, cancel this, cancel this, cancel this. Therefore T2 is 1059.188 Kelvin. So that is the final temperature. So I hope that this makes sense, guys. You can ask me questions in the comment section below, and thank you for your time. Oh, for class B and C, I'm posting a problem set in the description box. So you need to answer that one, and please read the instructions. So this is only for grade 11 STEM B, C, and two irregular students from grade 12 B and D. So please take note. Thank you for watching.